Good morning. In this class, we will discuss the topic we are going to discuss is line, surface, volume integrals, gradient, divergence, and curl in the subject electromagnetic fields. These are the reference books. How to define a line integral, surface integral, and volume integral. So, line charge distribution is a charge distribution in which the charge is distributed in a line. That is like a filament, a line like a filament. Okay. So the electric field due to line charge density is given by E equal to integral rho L dl. So E is that is the electric field intensity is given by Q by 4 pi epsilon 0 r square. From the Coulomb's law, if we derive, E is equal to Q by 4 pi epsilon 0 r square. So here the charge, instead of the charge, I am replacing it with, since this is a line charge, it is rho L dl. So E vector equal to rho L dl by 4 pi epsilon 0 r square. AR is a unit vector and the unit is Newtons per coulomb. Similarly, surface charge, if you consider the surface charge, we have to replace Q with surface, since it is surface charge, rho S ds, where rho S is the surface charge density, and this is with regard to differential surface. When you consider the line charge, it is differential length, okay. Newtons per coulomb, again the unit is Newtons per coulomb. And you consider volume charge density, so here instead of Q, I am substituting E equal to integral rho V dV. For Q equal to rho V dV. The charge is volume charge, okay. Rho V dV by 4 pi epsilon 0 r square AR unit vector, Newtons per coulomb. So this is the line, surface, and volume integrals. This is how we are representing line, surface, and volume integrals. Next we will discuss about what the three operators. There are three operators. There is a gradient, divergence, and curl. So let us see one by one. First one is gradient. How do you define a gradient? The gradient means, from the name itself we can understand that gradient means change. What is the rate of change? Okay. So the gradient of a scalar field. Gradient is for scalar field and its output is a vector. Okay. So the gradient of a scalar field is a vector that represents both the magnitude and direction of the maximum rate of increase of V. So what is the magnitude and direction of the rate of increase of the scalar field V? So that is called the gradient. Okay. Gradient is of a scalar field is a vector. Okay. And this representation of gradient is del. So del V. Okay. Suppose V is a scalar field and we are finding the gradient of the scalar field V. We have to represent it as del V. Okay. And we are representing in three coordinates what are the gradient operators. Okay. In three coordinate systems. In Cartesian coordinates, dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. In cylindrical coordinates, del v is given by dou v by dou rho a rho plus 1 by rho dou v by dou phi fi plus dou v by dou z az. And in spherical coordinates, del v is given by dou v by dou r ar plus 1 by r dou v by dou theta a theta plus 1 by r sin theta dou v by dou phi a phi. So this is about the gradient. Gradient of a scalar is a vector and it represents the magnitude and direction of maximum rate of increase of V. Next we will discuss about divergence. So divergence means net outward flow of flux per unit volume. So remember, divergence is outward flow of flux per unit volume. What is the net outward flow of flux per unit volume? As the volume shrinks about P, as the volume falls to 0, okay, shrinks about the point P. Okay. Look at the diagram for this divergence. So this is the point P. The volume shrinks to point P. And this is the net outward flow of flux. Remember, outward flow of flux. So this is the positive divergence. Or sometimes this the lines of fields may be converge at this point P. This is called negative divergence. And if there is no divergence, remember all these arrows are point in the same direction or parallel. So here there is no divergence. Okay. So positive divergence, negative divergence, and null divergence. And here also the divergence operator is given by dot, del dot A, okay, where the gradient is represented by del V or del A. So here del dot A, and remember divergence of a vector is scalar. Divergence of a vector is scalar. So del dot A equal to, here we have Ax coordinate alone. Remember, in the gradient we take A, the whole vector as V. Here we are taking as Ax, that is x component alone. Okay. So del dot A equal to dou Ax by dou x plus dou Ay by dou y plus dou Az by dou z. Similarly, in cylindrical coordinates, 1 by rho dou by dou rho of rho a rho plus 1 by rho dou a phi by dou phi plus dou Az by dou z. Similarly, in spherical coordinates, here we are representing the divergence. And coming from the divergence, from the divergence theorem emanates. Okay, how do you define the divergence theorem? Divergence theorem states that the outward flux, so divergence means net outward flow of flux. So the outward flux is equal to the volume integral of the divergence of A. So net outward flow of flux through the closed surface. Yes, so suppose this is a closed surface. What is the outward flow of flux from this closed surface? This is the same as the volume integral of the divergence of A. Volume integral of the divergence of A. So it relates surface integral to volume integral. Remember, divergence theorem relates surface integral to volume integral. That is closed surface A dot ds equal to volume integral del dot A dv. Del dot A means divergence. That is volume integral of the divergence of A. Net outward flux is equal to the volume integral of divergence of A. So this is the divergence theorem. Then curl is a rotational field. So curl is a rotational field. The curl of A is a rotational vector whose magnitude, the magnitude of the curl is the maximum circulation of A. So as we know, it's a circulatory field. So maximum circulation of A per unit area as the area tends to 0. So this is the, remember, the divergence of a vector is a scalar, but curl of a vector is another vector. Curl of a vector is another vector. It has both magnitude as well as direction. Okay, so here direction components also exist. So the direction is the normal direction of the area. Normal means perpendicular direction of the area when the area is oriented so as to make the circulation maximum. So this is how we can define the curl. Curl is a rotational field. Rotational field, and curl of a vector is another vector. Curl of a vector is another vector whose magnitude is the maximum circulation of A. What is the circulation of A per unit area? And direction is the when the area is oriented so as to make the circulation maximum. This is how we can define curl, and curl is usually founded by determinant value. Okay, so curl of A, del cross A equal to limit del s tending to 0, line integral. So here it integrates line integral to surface integral, while the divergence integrates surface integral to volume integral. Curl relates line integral to surface integral. So there is line integral A dot dl by del s, an max. So this is the formula for curl. Here also we are representing it as the 3 coordinate systems. So easily we can, so instead of writing a long equation, we can easily represent it determinant form. Okay, so del cross A equal to ax, ay, az, dou by dou x, dou by dou y, dou by dou z, ax, ay, az. So when you evaluate this, del cross A equal to ax into dou az by dou y minus dou ay by dou z, minus ay into dou az by dou x minus dou ax by dou z, plus az into dou ay minus dou ay by dou x minus dou ax by ay. So this is how a curl is represented in a Cartesian coordinate simply as in determinant form. Similarly, this is for cylindrical and this is for spherical. So in cylindrical, dou by dou rho, dou by dou phi, dou by dou z, வெளியே 1 by rho. Okay, so here this is for spherical coordinates. So this is how we have defined divergence and curl. Then just how divergence theorem comes from divergence, Stokes theorem arrives from the curl. Okay, Stokes theorem states that the circulation of a vector field A around a closed path L. So this is the circulation of vector field around a closed path L is equal to the surface integral of the curl of A. Surface integral of the curl of A. So del cross A means curl of A. So it integrates line integral to surface integral. Curl of A over the open surface S. This is the open surface S bounded by the closed path L. This is the incremental surface ds. So this is how Stokes theorem is defined. That is line integral A dot dl equal to surface integral del cross A dot ds. Once again, we have two more fields. That is, we have defined divergence and curl. Then if the divergence is 0, then it is called a solenoid field, and if the curl is 0, then it is called a lamellar field. Okay, a lamellar vector field is a vector field with no rotational component or irrotational field. That means the curl of the vector is 0, del cross A equal to 0. Similarly, a vector field with divergence 0 is called a solenoid field. That means del dot A equal to 0. Del dot divergence 0 means it is a lamellar, it is a solenoid field, and curl 0 means it is a irrotational or lamellar field. Okay, So what is the significance of divergence and curl mean? Divergence gives net outward flow of flux per unit volume, and curl measures the tendency for the vector field to spin around, circulation fields. Curl means it is a circulation field. Helmholtz theorem is one important concept. It states that any sufficiently continuous vector function can be represented as the sum of the gradient of scalar function plus the curl of the vector function. So f equal to minus del v. So del v is the gradient of a scalar function. V is the scalar function plus curl of a vector function. So we are representing scalar function as v and vector function as a. So gradient of scalar plus curl of vector. So any vector, any continuous vector can be represented as the addition of gradient of scalar and curl of vector. So this is called the Helmholtz theorem. Next, coming to the null identities, there are two null identities. One says that curl of the gradient is 0 and another says that divergence of the curl is 0. If it is curl of the gradient, what is gradient? Del phi. Okay, if it is phi, del phi. What is curl of gradient? Del cross del phi equal to 0. Divergence of curl. What is curl? Del cross A. What is divergence of curl? Del dot del cross A equal to 0. These two are called the null identities. So we can prove this. So if you have a rotational field, then the divergence of the rotational field is 0. Okay, divergence of the rotational field is 0. Then if there is a gradient, the curl of the gradient is also 0. Thank you.